Okay, so we're going to work with simplifying these trig ratios. So to start off, these trig ratios, we got three of them, right? Or four, I should say. Sine 45 multiplied by cos 45 plus sine 30 times cos 30. If you plug this in, you'll get a decimal value. You'll get some really long decimals, but they want this to be in radical form. That way you can have it as exact as possible. So to show it in radical form, there's two things that come in really handy. We'll draw them on the side here. There's two triangles, and they're the two special triangles that you're probably used to seeing. And we'll use these as reference, okay? They're both 90-degree triangles. One of them has a setup that looks like this. This is the easiest way I always remember it, is like that. But you can also make a smaller version of this one, and we call it a unit. We'll use it in something called the unit circle, but in the smaller version, you end up with a hypotenuse of 1, okay? Which also means that the side lengths for this one, I should have done it in a different color. Oh, I did, actually. I didn't realize I was still on the line. Which means the side lengths are 1 over root 2 and 1 over root 2. So not quite as easy as 1, okay? Same concept. We have our other triangle, which is, you guys work in degrees, not radians, right? So let's do this in degrees. I should have showed that too. This is 45 degrees. This is 45 degrees, okay? Have you guys talked about radians, where this would be the same as pi over 4?
No.
Nope? Okay, we'll leave that off. Let's keep that off then. Our other two angles are 60 degrees and 30 degrees, okay? Now, there's a special triangle with these. This special triangle has the side lengths of 1, root 3, and the value of 2. But again, I can make a smaller version of this where the hypotenuse is 1. And the hypotenuse being 1 becomes really important for this idea of a unit circle. So our hypotenuse is 1, which is the same as our hypotenuse here. This side length is actually 1 divided by 2. This side length is the distance of root 3 over 2. So a little bit different here, okay? So the ones that are in red, they're similar triangles. They just have a hypotenuse of 1. The reason I wanted to show you that is it's really good if you do memorize this stuff, because it'll help you in solving exactly what these are, okay? And then I'll show you the unit circle after, where we can just reference everything. But as long as I can recreate these triangles, sine 45. Okay, so first of all, I got to figure out which of the triangles is 45 degrees. So is it triangle 1 or is it triangle 2? After a quick look, triangle 1 is the one that has degrees of 45. So I'm working with triangle 1, and I need to find sine. So sine 45 is the opposite over the hypotenuse, okay? Now, if I do this, I'm going to kind of split this down the middle. I'm going to write in black will be the bigger triangle. Opposite of our hypotenuse would be 1 over root 2, okay? And if we did this on our other version, we would have, well, I'll show you. It looks like it's going to be a little more trickier. Actually, no, let's do it one at a time. We'll do the black first, because I don't think I have the room for it the other way, and then we'll come back. 1 over root 2, okay? Cos 45, same triangle. We just use adjacent and hypotenuse. Well, that's still 1 over root 2. That works out. Plus sine 30. Sine 30, we're in the second triangle. Sine 30 is opposite over hypotenuse, which is 1 over 2. And cos 60 is adjacent over hypotenuse, which is 1 over 2 also. Okay? 1 over root 2 times 1 over root 2 ends up being, if you multiply the numerators and the denominators, the numerator is still 1, and the denominator, root 2 times root 2, actually just gives you the value of 2. Okay? And the other one, we get 1 over 4. And then we just have to get a common denominator here. To get a common denominator, we're going to get 2 over 4 plus 1 over 4 equals a value of 3 over 4. So we didn't even end up having this in radical form. I'll show you in the unit circle, and this is where the red triangles would have came in handy. I'm going to go down a little. In the triangle version, it's a little trickier because you end up dividing by ones, but you'll notice you'll get the same value. So I'm going to write this in red. It's the exact same question. sine 45, just so we can see the second version of it. Cos 45 plus, I think it was sine 30 cos 60.
Yeah.
Yeah, perfect. So I'm going to use those same triangles, but this time I'm going to use this other, these angles are the same because they're similar triangles, okay? For sine, that's opposite over hypotenuse. Well, that ends up being 1 over root 2. So I'll do this one time and then we'll infer from there. 1 over root 2 divided by 1. Okay, that looks a little tricky, except what is anything divided by 1?
1.
Close. What if like we had 5 divided by 1? What would that be?
Wouldn't it be like itself?
Yeah, so the numerator, whatever the numerator is. So because we've turned these triangles, all their hypotenuse to 1, we can actually just choose the opposite side or the adjacent side. We don't have to do that division after, because dividing by 1 is not going to change anything, and that's what's unique about the unit circle there. So I can literally just write for sine, whatever's the opposite side of that. Well, that's going to be 1 over root 2. Well, for cos 45, we go and look. What is the adjacent side? Well, the adjacent side is 1 over root 2. That's the same thing. And you're going to notice we're going to end up with the exact same thing. Sine 30, this one was 60 and this one was 30. So what's the opposite side? Because we're going to divide by 1. Well, it's just a half. And cos 60, what's the adjacent side? Well, that's also a half, because dividing by 1 does nothing. And we end up with the exact same answer we had before. Doesn't matter which of those special triangles we use. So both of those triangles, their values are the same. They're similar triangles, but their lengths are a little different. The unit circle is something you'll probably encounter a little later. Okay, and I just want to show you how you can use the unit circle, because it can be actually really handy here. I'll try to do the same thing over here with sine. Can I not draw there? Oh, I can't draw on this. That's interesting. Let me try one more time. No, it doesn't let me draw. Okay. I wonder if save image as. Sure. Got an idea. Quickly import it. Sorry for a little delay here. Import. There you go. Now we can draw on. Same question that we had before, but we're going to use the unit circle. So I'm going to rewrite it again just to show you what it looks like. So we had our sine 45, cos 45. So we're just redoing the same thing many different times. Sine 30, cos 60. That's right? Cos 60. Okay.
Yeah.
What's interesting about this unit circle is what I want to point out here is notice when this line is vertical, the height is 1, which means this circle's radius is 1. So any triangle I make here is like that little red triangle we made before. If I decide to make a, I'll do them on the side so it doesn't get too messy. But if I make a right angle triangle here, let's use the actual straight line tool. That hypotenuse is going to be 1 because it's touching the outside of the circle. If I make a right angle triangle here, hypotenuse is still 1. It's still 1. That's what's unique about the circles. The radius is always the same, okay? For our question, we're just going to stay in quadrant 1, so you don't have to worry about those other quadrant. I was in quadrant 2 there. I just wanted to muck that one up a little, but we're actually just going to focus on quadrant 1. So for sine 45, you can use this unit circle. It gets really handy. I'm going to make a right angle triangle with a 45-degree angle. So you notice this says 45 degrees. I'm going to create that right angle triangle right here. Okay. And what it's talking about when it says 45 is it means this angle down here is 45 degrees. Perfect. Okay. So what we're looking at, this is an X and a Y coordinate. Well, the X coordinate is just going to be whatever the adjacent side is. So cos here will always be X. Okay. And the opposite side will always be sine. Just because, remember in SOHCAHTOA, cos theta is equal to the adjacent over the hypotenuse, But since the hypotenuse is 1, cos theta is just going to be equal to the adjacent. That's because h is equal to 1 in this scenario. Same with sine. Sine theta is opposite over hypotenuse, but since h is equal to 1, sine theta is actually equal to opposite. So in this case, for our sine 45, and look, they got actually a little bit of a different value. It still works out. We'll have the exact same answer. Sine 45 is root 2 over 2. So I'll write it down here, root 2 over 2. They didn't use the, did they use the same value as us? Oh, maybe I drew my circle, triangle wrong. Oh, I might have drew those triangles wrong. Good thing I'm referring back to this. Oh no, we used the black triangle. Oh, that's why. Okay. Our adjacent side is also root 2 over 2. Root 2 over 2.
Sorry, no.
Did that part make sense?
Yeah.
Yeah. And then we have sine 30 and sine 60. Okay, so we'll quickly make those triangles. This one is sine 30. It's a little smaller. Sine is the opposite, which means we're talking about the height here. So that's 1 over 2. It's the x, it's the y value, I should say. And then if I make another triangle for 60 degrees, you'll see this one says 60. It gets a little messy here, I realize. But cos is the x value, and the x value, the x value happens to be a half also. So let's actually carry out the multiplication here. We end up with root 2 times root 2 is just 2. And 2 times 2, so numerator times numerator, denominator times denominator is 4. Plus 1 over 4, and we end up with the exact same answer of 3 over 4. So same thing, no matter which way we did it. I just want to make sure I didn't draw that triangle wrong before on the other page. It seemed to work out. Yeah, that should have been fine. Yeah. We got the exact same answer here. This unit circle, you may not have been introduced to it, but it's like a really fast way to reference stuff, and eventually you're going to get into the other quadrants. You're just kind of focused on quadrant 1 at the moment, but it's a good thing to get familiar with. It gets really, really handy.